All right, hello everybody. We are going to be doing 2.6. This is on asteroids, comets, and other planetary bodies. So there are slight differences between asteroids, meteoroids, meteors, and meteorites. These words all mean something slightly different. An asteroid is a large object in orbit around the sun made of rock or a mix of rock and metals. It can be anything from the size of a small car all the way up to the size of a dwarf planet. And as you may or may not realize, that would be something almost as large as Pluto, because Pluto is considered a dwarf planet. A meteoroid is a smaller chunk, usually something broken off an asteroid. It can be anything from the size of a small pebble up to the size of a car. So it is basically a small asteroid. A meteor is any meteoroid that has penetrated the Earth's atmosphere. These are often called shooting stars. That means it has to actually breach our atmosphere, and it generally then will start to glow because of the heat of friction when it hits the air. And a meteorite is any meteoroid that has survived all the way to the ground. So it only becomes a meteorite when it lands. It is not a meteorite until then. Okay, there are a few different types. C-type, these are the most common. These are called chondrites. They are dark and they're silicate rocks. They're basically rock. S-types are stony, made up of a mixture of silicates, which are rock, and nickel iron. Nickel iron is a metallic alloy, essentially. It's basically a little bit of nickel, a little bit of iron mixed together. Then there are the M-types, where they are considered metallic, and they are almost all nickel iron. So these are the ones that are a little bit more rare. Now, where do you find most of the asteroids in our solar system? Well, this diagram on the right kind of shows, all those little dots are where the asteroids tend to be. There are some that are found crossing our orbit. These are called near-Earth asteroids. So as you can see, when you get closer to the Earth, there are a lot fewer dots around there, but there are still, a bunch that are near our orbit. Most are found in the asteroid belt that's located between Mars and Jupiter. So Jupiter and the sun have a weird relationship that they kind of keep these asteroids in between them based on their gravity. These are remnants from the formation of the solar system. These are chunks that never got pulled into other planets. There are over 1,113,000 known asteroids. There must be many more that are unknown. Comets are different from asteroids and meteoroids. They are mostly rock and ice. That is a big distinction, a lot of ice. They have a hyperbolic orbit, which means they are not elliptical. They are going to come and they swing in, they go around the sun, and they swing way out away from the sun and then come swooping back in. When they get near the sun, they actually have two different tails. The gas tail points away from the sun, and the dust tail usually curves a little bit. So as you can see in the diagram on the right-hand side there, they show the direction of the sun. The gas tail goes straight away from the direction of the sun because it's blown by the solar wind. The dust tail kind of follows the path behind. As you can also see, these tails can be very long. They can extend up to 3.8 astronomical units. That's 3.8 times as far as the distance between the Earth and the sun. The comet core can be up to 20 miles in diameter. Some comets are larger than others. Some of the famous ones, there's Halley's Comet. That's the one that comes by every 76 years or so. Hale-Bopp came by in 1987. I got to see that one up close and personal. It was very bright in the sky. It has a 4,200-year orbit, so it's not going to be back for a while. And then there's Shoemaker-Levy, and Shoemaker-Levy was, it's done now because it crashed into Jupiter, and it actually broke apart on entry. And you can see on the very right-hand side, down at the bottom, there's all those glowing images down at the very bottom. Those are where the different chunks hit as Jupiter was was spinning in its rotation, and it just kept pulverizing it. And those were massive explosions, and they did a lot of, they were really evident in the atmosphere. The Oort cloud. The Oort cloud is something way, way, way out beyond even where our dwarf planets are. This is a cloud of icy objects surrounding the solar system, and this is where we think most of our comets come from. It's located between 2,000 and 100,000 astronomical units from the sun. The very long period comets, so 200 years or longer, come from this cloud. There may be more than 1 trillion icy objects out there. And it's named for Jan Oort, a Dutch astronomer who predicted it in the 1950s. So you can see in those pictures, it is a long ways out. It's kind of like this area that it's like a sphere outside of our solar system, a long ways outside of our solar system. Inside of that is what's called the Kuiper Belt. It's a donut-shaped region just beyond Neptune's orbit, with millions of icy bodies. It's similar to the asteroid belt, but it's just a little further out. Thousands of bodies larger than 100 kilometers in diameter, and it contains dwarf planets like Pluto, Makemake, Ceres, and you can see there where Pluto is definitely part of that Kuiper Belt. You can see that very elliptical orbit. That's the orbit of Pluto, and it sits out in that belt. So Pluto was a planet when I was young, but while I was in college, it went through a little bit of a change. So it got declassified as a planet. So the things that make it seem like a planet are that it's relatively large. It's only 2/3 the diameter of the Earth's moon, but it's still, pretty big. It has one moon and 4 small moons. It has a very thin atmosphere, and it orbits the sun, and one day is 153 hours long, so it spins pretty slowly. Now, ways that is no longer like a planet. It has not cleared its orbital path. That is a new criteria, and it has too many things in its path as it goes around the sun. It has a very elongated orbit into the Kuiper Belt, so it sits out in the Kuiper Belt. Its angle of orbit is not on the orbital plane. So if you would imagine all the plates orbit on like a plane, like if you'd set a plate out, they would all orbit within that plate. This one would cross through the plate at an angle. The moon is almost as big as Pluto itself, the moon Charon. It looks like Charon or Charon, but it's actually Charon. There are other Kuiper Belt dwarf planets about the same size, so Makemake and Ceres are actually quite similar in size. And there's other ones that they think are as big as Pluto out there as well. Other Kuiper Belt objects. So here is a list of a whole bunch of other things. So astronomers continue to find sizable objects out there, and this shows some of them. Triton, the moon Triton, Neptune's moon that we just learned about, is thought to be probably a captured Kuiper Belt object, one that came in too close and Neptune kind of grabbed onto it. The Earth's moon has been included to give an indication of size. So when you see our moon, you'll see that they're all smaller, but considerable in size. They're big enough to actually be spherical. And that is it for this presentation on asteroids, comets, and other planetary bodies.